So here are the notes for 15.1. Module 15, we start getting into some different properties of angles and triangles and other polygons that we'll talk about in just a little bit. But our essential question is, what can we say about the interior, right, the inside angles and the exterior angles? So your exterior being your outside angles, specifically of a triangle. And in this class, we're going to work a lot with triangles. We'll work with a little bit of other polygons too, which are just types of shapes. But triangles are a big one that we're going to work with. The first idea we're going to work with is this triangle sum theorem. You will need to know what it is, and that is simply that the sum, remember we are adding here when it's a sum, so the sum of the angle measures of a triangle is, hopefully you remember, 180 degrees. Okay, so all three angles in a triangle add up to 180 degrees. And below we have the proof for that. So why does that happen? Every single triangle, no matter how you draw it, well, this is why. And so this proof says, given triangle ABC, which is the triangle off to the right here, prove that angle 1 plus angle 2 plus angle 3 equals 180 degrees. So the first thing you're going to do is you're going to draw a line L parallel through point B parallel to AC. That's the parallel postulate, simply meaning that if I have a line, I can draw another line through a point that is parallel to that line. There's one line through this point, B, that will be parallel to AC. That's all that's saying. And so from that, we now have two parallel lines, which means that angle 1 right here is congruent to angle 4 because they are alternate interior angles. So we can say angle 1 is equal to angle 4, and then angle 3, similarly, is going to be congruent to angle 5 because those are alternate interior angles. So that is the alternate interior angle theorem. And the third step, says angle 4 plus angle 2 plus angle 5 has to equal 180. So all of these right in here, 4, 2, and 5 has to equal 180 because that's your angle addition postulate. If you add them all up, it equals the big angle, and that angle is a straight angle, so it has to equal 180 degrees. And so if we can say that angle 1 is equal to angle 4, well, that means that anywhere I see angle 4, I can plug in angle 1. Well, look, there's an angle 4, so I'm going to write angle 1. And similarly, it says that angle 3 is equal to angle 5, so anywhere I see angle 5, I can plug in angle 3. So we have plus angle 2, and there's our angle 5, so I'm going to plug in angle 3. And so anytime I do that, anytime I plug something in for something else, that's called the substitution property. Oops, let's try that again. Of equality. Okay, so that's why it works for every single triangle. And then I'm going to have you go ahead and just answer this reflection question. What does the triangle sum theorem indicate about the angles of a triangle that has three angles of equal measure? So if we have a triangle and all of them are the same, now if I call this one x degrees, and x degrees, what does that mean? Well, again, if all three angles, x plus x plus x, has to add up to, you guessed it, 180. And 3x has to equal 180. Divide by 3. And so x must be 60 degrees. And we'll get into that a little bit more later on, but that's just kind of a precursor of what's to come. And then determining interior angles in a polygon. So it says to determine the sum of the interior angles for any polygon, you can use what you know about the triangle sum theorem by considering how many triangles there are in other polygons. For example, by drawing the diagonal from a vertex of a quadrilateral. So vertex is just a corner. Okay, that's what a vertex means. And a quadrilateral, right? Quad means 4, so we have 4 sides. You can form 2 triangles. So that's this dashed line right there. Okay, that's the diagonal it's talking about. The quadrilateral must have an angle sum of, since each triangle has an angle sum of 180, the quadrilateral has to have 2 of those, right? This 1 and 2 triangles make 180 apiece, so 180 plus 180 equals 360. So go ahead and turn the page. And so it says, draw the diagonals from any one vertex for each polygon, then state the number of triangles that are formed. The first 2 have already been completed. So you'll notice I pick one vertex, doesn't matter which one, and I'm going to draw all the lines I can from that vertex to my other corners. So, well, unfortunately that didn't make anything else, so I still have my one triangle. Now for the quadrilateral, again, if we start here, draw a line to all of my corners. Oh, hey, look, now I have 2 triangles, 1 and 2. And so if we go to this next shape, I'll do this one with you. Here's my vertex, draw a line. And now we have 1, 2, and 3. So go ahead and fill the rest of that out, and then you'll notice down here below there's a table. And so for each polygon listed, I want you to list the number of sides, the number of triangles, and then what the sum of those angle measures would be. So for example, it does the first 2, a triangle has 3 sides with 1 triangle, so 1 times 180 is 180. A quadrilateral has 4 sides, had 2 triangles, so 2 times 180 is 360. Something that might help is to first go ahead and do just these 2 columns here, a polygon and number of sides. And you may need to look these names up if you don't remember these or don't know how many sides these have. I would go ahead and Google these, because if you're gonna do this right, you're gonna need to make sure you know how many sides are in each one. Now most of them are up here in this section at the top of the page, but some of them might not be. Okay, so you need to go ahead and look that up. So I'll give you a second to try to fill out as much of that as you can. So this is a good place to pause before I fill out the rest of it. So a pentagon has 5 sides. Let's try that again. 5 sides. A hexagon has 6. A heptagon has 7. A decagon has 10, right? Decade, 10. And an n-gon has n number of sides. So I don't know how many it is. I just know it has some number of sides. It's like a variable in this case. And if you notice the pattern here, if we had 3 sides, we had 1 triangle. 4 sides meant 2 triangles. So 5 sides would be 3. 6 would be 4. 7 would be 5. And if you notice the pattern here, what's happening between the number of sides and the triangles? Well, 3 to 1, 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. So 10 minus 2 would be 8. And n, I don't know what n is, but I know it's ultimately going to be whatever n minus 2 is. So I'm just going to take whatever n, subtract 2, and that's going to be what we have. And then the sum, the angle sum, is going to be 3 times our 180, which is 540. 4 times 180, 720. 5 times 180, which is 900. And then we have 8 times 180, which is 1,440. And really, these should all have degrees, right? Because we're talking angle measures. Now, this last one, right, I may not know what n is, but I know the number of triangles is n minus 2. So I'm going to take whatever n minus 2 is, multiply that by 180. And that's okay, right? When we know how many sides we have, we can use that later on. So make a conjecture for a rule that would give the sum of the interior angles for any n-gon. So go ahead and make your conjecture there. I'd go ahead and pause it for a second so you can write that. And now we have the polygon angle sum theorem, another big theorem to work with here. Okay, the polygon angle sum theorem, angle sum, right? Adding the angles. The sum of the interior angles, so the inside angles of a convex polygon, and really all this means convex means it looks something like this, where everything is kind of inside of it. It doesn't have any weird shapes that jut out or anything like that. Okay, so that's really what that means. Nothing to really worry about with n number of sides is that expression we just found, n minus 2 times 180. So number 2 says, for the nonagon shown, find the unknown angle measure x. So we have this nonagon. I need to find x, and if you're not sure what a nonagon is, just simply count the sides. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 sides. So ultimately, all of them should add up to this expression. 9 minus 2 times 180, so that's 7 times 180, which is 1,260. So I know that all of those should ultimately add up to 1,260. Now you can write this all in one step if you want, but that would be a lot of writing and it's going to be a really long strand. So what I would do is I would simply take each number, each of my angles here, my interior angles, and add them all up. So if we go ahead and do that, we have 125 plus 130 plus 172 plus 200 plus 140 plus 102 plus 98 plus 135 gives us 1,102. So 1,102 plus that last angle x has to equal that total of 1,260. So if we take our 1,260 and we subtract by 1,102, in this case subtract 1,102 from both sides, x is going to equal 158 degrees. Okay, so that polygon angle sum theorem, that n minus 2 times 180, okay, that's what's going to tell us what they all have to add up to be, which can be really useful if you know some or most of them, and then you can figure out what's missing from there. So numbers 3 and 4, okay, I'm going to give you a moment to go ahead and try those out. So go ahead and pause the video, try to work on those, and then come back for the answer. So number 3, determine the unknown interior angle measure of a convex octagon in which the 7 other angles have a sum of 940. So an octagon has 8 sides, and so the total is going to be whatever 8 minus 2 times 180 is, which is 6 times 180, which is 1,080 degrees. So they all have to add up to 1,080. Now it tells me that these 7 other angles add up to 940. So 940 plus my missing angle has to equal that 1080. So we're going to subtract 940 from both sides. And x will equal 140 degrees. So again, that's where knowing that little expression there, the n minus 2 times 180, can really be useful. And then number 4, determine the unknown angle measures in a hexagon. So a hexagon has 6 sides, whose 6 angles are 69, 108, 135, 204B, and 2B. So again, we'll start with our polygon angle sum, n minus 2 times 180 is 6 minus 2 times 180, or 4 times 180, which is 720 degrees. So all of those 6 angles have to add up to 720. So what I would start doing is adding up all of the just number ones. So 69 plus 108 plus 135 plus 204 equals 516 plus B plus 2B has to equal that 720. So these were all of the 4 angles that I knew, and then B and 2B were my last 2 from up here in the problem. Okay. So we have 516 plus B plus 2B, well that's 516 plus 3B equals 720. We're going to subtract 516 from both sides. So we have 3B equals 204. Divide by 3. And so B equals 68. So B equals 68 degrees. 2B is going to be 2 times that. So 2 times 68 is 136 degrees. Okay. So again, if you have any questions there, make sure you come talk to me, but it's using ultimately this polygon angle sum theorem back up here at the top, or kind of in the middle of your page. Okay, that's kind of one of the big ideas for this section. And then the last page, we have the exterior angle theorem. Okay, your exterior angle theorem. Exterior, right, remember, means outside. So this says the outside of angle of a triangle is equal to the sum, so again, adding, the measures of the remote interior angles. Okay, when you're using a TV remote, why do you use a TV remote? Because you're right next to the TV and you hit the TV with the remote, right? That's how you get it to change the channel. No, you use a remote because we're lazy and we like to sit on a couch and we like to change the channel without having to get up. Or in the case of Netflix, we don't like the little screen that pops up asking if we're still watching. Yes, we're still watching after 3 hours. So our remote, right, allows us to be far away. Okay, I'm going to rewrite that because I know that was bad. Far away. And interior, again, just means inside. So the exterior angle, the outside angle, is equal to the 2 farthest away angles added together, is really what that says. So in this case, if we have this triangle, our exterior angle is the one outside of my triangle. And these 2 that are the farthest away, right, not number 3, because number 3 is right next to it, okay, but the 2 that are farthest away, those we call remote interior angles. Okay, so it's those two. And really what this is saying is ultimately that angle 4 equals angle 2 plus angle 1. Okay, those two angles, those remote interiors added together equals your exterior angle. So the proof, angles 3 and 4 are a linear pair. That's given from your diagram. Angle 1 plus 2 plus angle 3 equals 180. That's your triangle sum theorem. So we have angles 3 and 4 are a linear pair. 1 plus 2 plus 3 equals 180. Well, if we know that 3 and 4 are a linear pair, that means we can also say that the measure of angle 3 plus the measure of angle 4 has to equal 180, and that is by your linear pair theorem. And since they both equal 180, that means they both have to equal each other. So we can write this line from number 2 here, angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3 has to equal the measure of angle 3 plus the measure of angle 4, and that is by our transitive property. Again, you could also use substitution there. They're pretty much the same thing. And then for step 5, and we kind of skipped a step here. I really should have said that because these are a linear pair that they're supplementary, and then that they're supplementary leads us to this. But for this case, I think we'll be okay. And so at the end here, we see this equation, and we should recognize that angle 3 is on both sides of the equal sign, so we can subtract it. And if we do that, we're left with just measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And that, since we subtracted from both sides, is called the subtraction property. So that's the proof there. Again, the big idea is simply that the outside angle, angle 4 in this case, is equal to the two faraway inside angles added together. So then go ahead and pause the video here and try 5 and 6, and then I will go over them in just a second. So number 5, again, our outside angle equals our two remote interiors added together. So for this case, we have 145 equals 2z plus 5z minus 2. So 145 equals 7z minus 2. And so we're going to add 2 to both sides. 147 equals 7z. Divide by 7, and therefore z equals 21. And our problem says determine the measure of the specified angle, find angle B. So that's our 5z minus 2, so angle B equals 5z minus 2. So if we substitute in 21, angle B is going to be 105 minus 2, which is 103 degrees. And then for number 6, again, our exterior angle is equal to our two remote interior ones, the ones farthest away. So we have 3x minus 8 equals 90 plus x plus 2. So we have 3x minus 8 equals x plus 92. I'm going to subtract x from both sides. So we have 2x minus 8 equals 92. Add 8 to both sides. So 2x equals 100. Divide by 2. X equals 50. Now does the problem say to find x? No, it says to find angle PRS. So angle PRS is my exterior angle. All right, the one that occupies that space. So 3x minus 8. So angle PRS equals 3x minus 8, which is 3 times 50 minus 8, which is 150 minus 8, which is 142 degrees. Okay, so again, the outside angle equals your two far away inside angles. Okay, that's kind of the big idea there. And lastly, our essential question check-in, summarize the rules you have learned about interior and exterior angles of polygons. Okay, so we have a couple theorems, a couple rules here that we've talked about. Go ahead and just summarize them in your own terms. Maybe make a couple bullet points. These, again, are just for you to kind of organize your thoughts. And then, again, don't forget to upload your notes once you have finished writing them.